Today we're going to look at finding similar figures using fractions. So we've done similar figures a multitude of ways, and so today we're going to look at specifically what happens when they give you fractions to work with. Before we start moving on to how to use these fractions to get our similar figures, we're going to do a quick fractions refresher. Multiplying fractions was super easy. We had a little chant that we did, and it was multiplying fractions, that's no problem, top times top and bottom times bottom. So I want you to write in your little box, top times top and bottom times bottom. Easy enough. Give you a second to write that down. Now, what about dividing fractions? No, it was not Kentucky Fried Chicken, even though y'all like to say that. It was keep, change, flip. So we're going to talk about what each one of those means. First thing we had was K for keep. And that's because we had to keep our first fraction. Then we had our change, and our C for change, because we have to change the divide to a multiply. And last one was flip, and that's because we flip the second fraction. Once we've done all of that, you have to multiply across, which top times top, bottom times bottom. Okay, so our first problem. A giant pine tree is 24 feet tall with a shadow of 16 feet. If a smaller tree is only 3/4 of the size of the large tree, what would the height of the smaller tree be? Okay, so first thing I'm going to do is I'm going to label. I have a pine tree that is 24 tall, and it is 16 feet long. But I don't know what the height or the of the tree or the shadow is for the next one. But that's easy enough, because if it's 3/4 of something, all you have to do is multiply. Now, remember 24 is always over 1 because it's a whole number. And I know it's going to be 3/4, so I'm going to multiply by 3/4. Multiplying fractions, that's no problem. Top times top and bottom times bottom. So I'm going to have to do 24 times 3. So I'm going to come over to the side, 24 times 3. 4 times 3 is 12, carry over my 1. 2 times 3 is 6, plus 1 is 7, which makes 72. And then 4 times 1 is just 4. And to get that as, it's a improper fraction, so to get that as a plain number, I'm going to have to top in, bottom out. So 72 is going to go in the box. 4 is going to go outside. And 4 goes into 7 one time, which gives me 3 left over, bring down my 2, and 4 goes into 32 8 times. So that gives me none left over and a height of 18. Now, all it wanted was the height. Do I need to find a shadow for it? No. So I can just put my height was 18 feet. And that's my answer. Okay, so let's look at this problem. An equilateral triangle was multiplied by 1/3 to get a triangle with a side of 6. What was the side length of the original triangle? First of all, I want you to notice that it says equilateral, which that tells me all sides are the same. So if this one's 6, that means they are all 6. Now, what happens when I multiply by a fraction? It gets smaller. So what that tells me is I'm trying to find the side lengths of the larger triangle. And they tell me I multiply by 1/3. Well, now that I'm trying to get back to my big one, I have to do the opposite. So what's the opposite of multiply? Divide. So since I multiplied by 1/3, I'm now going to have to divide by 1/3. And this is why we went ahead and went over by dividing fractions. So, and we said to do that, we're going to have to keep, change, flip. So we have 6 divided by 1/3. So if I keep, change, flip this, I'm going to keep the first fraction, which is a plain 6, but I know that's 6 over 1. Change my divide to a multiply and flip my 1/3 to 3 over 1. So I now have to multiply my fractions. So top times top, 6 times 3 is 18, and 1 times 1 is 1. So 18 divided by 1 is just 18, and there's my answer. Okay, last one. A rectangle was multiplied by 2/3 to get a rectangle that has a length of 6 and a width of 8. What was the dimensions of the larger triangle? Notice it says dimensions, so that means we're going to have to find both the length and the width. All right, so we have a length of 6 and a width of 8. Now, if they had to multiply from my bigger triangle to my smaller triangle to get 2/3, what is the opposite? Because remember, I'm going backwards, so the opposite of multiplying by 2/3 is dividing by 2/3. So, here we go. We have 6. I'm going to start with my 6 first. So, 6 divided by 2/3 is, still do my keep, change, flip. So 6 over 1, change the divide to a multiply, and flip my second fraction. So it's going to become 3 over 2. So 6 times 3 is 18. 2 times 1 is 2. That gives me 9. Next one. So that gives, and since 6 was my length, that means my length of my larger triangle is going to be 9. Now I have to do my width. It was 8. So I'm going to do the same thing. 8 divided by 2/3. Well, I have to keep, change, flip that. So 8 over 1. Change the divide to a multiply and flip my second fraction. So it becomes 3 over 2. 8 times 3 is 24. 2 times 1 is 2. 24 divided by 2 is 12. And since 8 was my width, that means my width of my larger one is going to be 12. It's that simple.